So this is a talk called Blue is the New Green, right? And it's about how things tend to blow up. And one of the ways that at my previous employer, we worked around some of the constraints that we had around pipelines and how we had things integrated into those continuous delivery pipelines. So speaking of that, not long ago, this was a ideal pipeline that we had, right? Where we had the idea, designed it, architected it, developed it, committed it, really simple, right? Nothing really crazy. This is the way I left it one day when I went home. And next morning I got up and was enjoying a cup of coffee, not unlike this stock photo art model. And, I was like, okay, I'm gonna check my email and see what's going on in the day. And I had like hundreds of messages about things that were broken. And I was thinking, man, like something is really going wrong here. So there's a lot of funny slides in here. I thought, we've been listening to some crazy stuff all the time. So, and the pipeline had broken. So I was like, okay, what's going on here? And went into work, if this actually does work, and a security tool that we were going to add. I don't know if anyone's read the Phoenix Project, but this is like real life Phoenix Project, right? Where security comes in, we throw this tool in, and we realized a little bit later that it was just like the wrong tool to put into the pipeline because everything just went and it blew up. The thing was running for 72 hours. So this was a piece of code that when it was going through the pipeline, it was 4.8 million lines of code. And it hit this static analysis and security testing tool, which is looking inside the code, seeing what kind of vulnerabilities are in there. And it was holding everything up. So this tool looked like it was jammed, but really it wasn't. It was just the wrong tool. And it was configured improperly as well. So we were letting developers self-serve and get onto the static analysis platform themselves. So what they would do is they would say, okay, well, we're going to scan all the code, even our third-party dependencies that is code that we didn't write. So now all of a sudden it's going through hundreds of lines of jQuery and Apache struts, whatever, just to try to get things going. And we ended up working a lot of overtime trying to figure out what it was. And then we realized it was this tool that was in the way. And some of the other talks I've talked about, epic failures of DevSecOps, if you haven't grabbed a copy of the book, it's at the Sonotype booth. But a lot of the stories are about that because we ended up spending a ton of time trying to figure out how we could scale this tool, why it wasn't working, and why it was only working on one EC2 cluster. And when we scaled it to 40 EC2 clusters, we ended up spending more on the tool or in the infrastructure than the actual tool licensing itself. So it's going to go back a little bit, and some of the investigation that we did was on why things fail. And complex systems are not maintainable. And like a power line or network, a neural network, you take one piece of it out, and trying to figure out where that break happens is almost impossible. So, we can talk about adding different things into pipelines and doing everything, and everybody's putting these tools in. But really, if you're putting all this complexity into your pipelines and your development processes, then it's not going to be really maintainable. And why is that? There's a couple of reasons why. First off, we pack way too much shit. There's too much stuff in our development pipelines that we don't even know it's there. Yeah. Don't bother taking a picture of this because I can give you some links to it. I did this. And I did this last year, and I read this book called Essentialism. And I might have been talking to a lot of you about it. If you haven't read it, it's The Relentless Pursuit of Less. And this was sort of the idiotic pursuit of a lot. But it's everything that I thought about doing when I was enterprise security architect and that I didn't get a chance to do. So really, this is just a possibility diagram. We printed this out, we gave it to a lot of folks, and they've said, these are ideas. And everyone's like, well, I'm not even going to take that because we're never going to get to this maturity in DevOps. And even if we did, it's just going to be way too complex to maintain. So second problem is we didn't know what we packed in the first place. So, these are a whole bunch of different security tools that you can have in, right? So, we have infrastructure as code, security as code, we got XYZ as code, we got RASP, we got DAST, or dynamic application security testing, and it's bleeding because you want to bleed out because it takes so long to do. And all of these different things, like MAST. Anybody know what MAST is? Show of hands. MAST? I didn't either. I was like, what the heck is this? I'm doing the 2020 or 2020 DevOps community survey, DevSecOps community survey, and one of the do you use MAST was in there. And I was like, MAST, mobile application security testing. So I asked some of my friends who are in the mobile industry who are doing tools there, and they're like, I had never heard of that term. So we took it out, but I don't know if you see there's something else in there. It's a Trojan, yes. Anybody scan vendors' tools when they come into your environment? Show of hands. Like, we all scan stuff, right? Oh, you do. One. Awesome. Maybe-ish. Well, it depends, right? So this is a little segue story. I had a container, an image that was forwarded to me, and it was one of these applications that one of our teams wanted to use. And they're like, okay, it's an image. We've never gotten an image to run. Can you take a look at it and see what's going on with it? So I ran it through two security tools. One was looking at the operating system itself. One was looking at the open source components that were in it. And there were 9 critical vulnerabilities in this thing that it was like putting a Trojan horse in our environment. And we were implementing this into our pipeline, right? Which is, I wouldn't give software to the public that had that many vulnerabilities, and these guys are giving us, extreme critical vulnerabilities in there. So, if you haven't, or if you're not looking at it, it's, I did a talk called "Declare War on Your Vendors," and I work for a vendor now. So, what I'm saying is that you're going to want to make sure that the stuff that you bring in is just as secure as the stuff that you want to go out, and it's just good corporate citizenry to do that. Problem of 3 is we forgot what's essential, right? We could pack all the clothes in our suitcase and go on a nice trip, but if we don't have a toothbrush, then we're like, dang it, like I could just wear the same clothes, but I can't brush my teeth. I like brushing my teeth. So, we forgot what was essential, and really, we're developing software for our customers, right? We're not developing software because it's fun, or, it is fun, or we're going to use the latest and greatest new tools. We can add all that stuff in, but again, it's just adding complexity. We're trying to do safer software sooner, right? And then when we develop in production, everyone fist bumps, right? Like, you don't develop in production. And really, our pipelines are production. Normally, we just have one of them. And have you ever thought about like manufacturing cars? And in 1986, there was a security feature added into a lot of vehicles called a high-mounted brake light. And now it's just like this brake light on the back of your car. It's a little bit higher than the rest of it, right? I thought they were super cool because I was like, wow, there's this magical brake light flying at the top. But did people just say, hey, you know what, in our assembly line, we're just going to jam in this station to put this high-mounted brake light in? No, people had to turn off the assembly line, or GM, Ford, whatever, get the supply chain in order to bring that part in, and then have the ability to install the part and potentially pull a cord stopping the assembly line if the car got too far and they couldn't get the part in on time. So it's not something that they could just do without shutting it off. And we might not have the luxury to do that when we're doing continuous delivery because we shut a pipeline off and the code's not going out to our customers. So pipelines are the forgotten ones. So we take our pipeline and think about, or your pipeline, and every little dot there is like a subway station. I always do little diagrams like subway stations. If you take the New York subway system and you look at all the stops there and then you overlay it onto Tokyo, you're going to have Brighton Beach Station in Tokyo Bay. So like subways are only good for the cities that they're in, just like a DevOps or continuous delivery pipeline is only good for what you do. Right? It might not be good for another team. Even if you have 15 teams in an organization, everyone might have a different one because they're doing different things. So, take your pipeline, copy it or clone it, and now you have 2. So you have a blue and a green one. And then for, shits and giggles, we'll just call one blue and one green. So this is blue-green deployment, but it's blue-green for pipelines. Right? Everyone knows about blue-green deployments, right? Ish. Yeah. Well, we got this definition, but we don't care. basically, it's like putting something to production, testing it out like in a production-like environment, and everything looks good, you flip it over, right? So we started doing this with our production pipelines on a lot of different teams. We started with one team and said, hey, let's take what you're doing and we'll copy it. And when the code starts going through, we're going to run it down 2 separate paths. And I remember using Go CD and a whole bunch of different applications and trying to get these pipelines running in parallel. And I just came up with the idea, hey, we're going to use infrastructure as code. We're going to bootstrap our production pipeline and this copy, and then we're going to start doing some experimentation. So, think about that experiment here, that little red subway station. That could be putting in a security tool. It could be putting in any kind of tool or any kind of functionality to get that product out to your production environment and to the customer. So this was really essential for us because we had 4 different security controls that we wanted to put in. It was sort of our 4 horsemen of the DevSecOpocalypse, for that matter, which was static analysis, dynamic analysis, and security testing. There was container vulnerability analysis, and then open source software management. And SAST and DAST are 2 regulatory security controls. So if you're doing PCI or you're doing HIPAA, that's sort of the things that you're putting in here, and they're both absolutely useless, and it's like watching paint dry. So in this state where you have this pipeline, you're still doing your production stuff. You're creating a duplicate of that, adding the control and saying, does it add any value? Like, why are we putting it in here? Where does it go, right? So like if you have a open source software scanning tool, which is looking at all the open source components and seeing where the vulnerabilities are, you can put it anywhere, right? You can have it on your developer machine, it can run there. You can have it weighed, right in the pipeline before you go out to production, or you can have it before you do your check-in and have it look for vulnerabilities and then just fail it left. So it's so fast, you can do it there. But would you put static analysis before that? Well, you have to, because it's looking at the code and it can't be compiled. But if you're waiting 72 hours, then what do you do, right? And is it useless? Like, think, for example, if you don't have any PHI or PII that's revolving around health or PCI related credit cards or things like that, why are you scanning for it? Like, don't put something in there that's looking for vulnerabilities around PII, PHI. This is sort of a useless thing to put in there. So feedback, right? Getting that communication back about something. That's another thing you can do in these green pipelines, which is like, read the effing manual. Like, create a plan so that when you implement this tool that you're not leaving the developers hanging if it breaks. So, security adding that SaaS tool in there, well, nobody knew what to do, and they reached out to us, and I'm drinking my coffee in the morning trying to figure out what my email is, and I'm like, oh man, we didn't tell them how to maintain it or that they could turn it off. What they ended up doing was just removing the tool completely, and a couple days later my boss is saying, hey, well, why isn't this control being used? I'm like, well, we're trying to figure out why it's not working, and it turned out to be a scalability issue. Logging and observability, one of those essential things that we want to have into our pipelines. See before you even put it in to your production pipeline, like, what can I do here? What kind of information can I get out? Can I see when it fails, and can I get that to a developer in a relevant way? Can I automatically create a work item, or do I need to create a work item? Will it automatically create a pull request for me so that things can get remediated right away? So there's that, and then flow. So looking at things like a stage detail, when you're seeing all these steps, and then you get to this one, is something waiting to go in? Like, that static tool was blocking everything else from going in. So we had like 20 builds queued up behind it, and different teams were thinking that something was broken, but really we're just waiting on that one big piece of code to go through. And then stage lag, I don't know if you can see that down here, but well, my laser beam isn't working, but nope. Stage lag, how long does it take between an execution of one control and the other? And that was a huge one too. Is like, there could be network latency. So some things of looking at, like, what's the impact of adding this control or this build tool? It doesn't have to be security, it could be something else. So if you're adding something, does it make sense? what kind of impact we have. Is it slowing things down? Is it speeding things up? And then the impact of removing things, right? If you have this complicated pipeline and you're like, why do I need that there? Well, see about taking it out and seeing if the impact or if the application is getting out in the same quality level as it was before, or maybe with a reasonable risk or reasonable level of difference, I guess you could say. Look at the impact of tuning it. Like, is there other ways that you can configure this tool to run faster? And again, it's just running parallel. You're not affecting any production. You're just experimenting and doing things to see if they work. And then network latency as well is a big one that I just mentioned, which is, if you have different build tools and different networks or subnets, or if you're doing things in different availability zones in AWS, and you're passing data or passing some code or some sort of artifact between these tools, like, are you spending money on it? Is there a latency issue where things are taking a lot of time? Is it a secure channel? That kind of thing, right? And that's even instead of a Kubernetes cluster, if you're just going from pod to pod, for example. So once it looks good and everything's fine, did you know this guy retired 4 years ago? There's some new guy, I have no idea, but he drinks Dos Equis as well. Swap it. So make one, take that pipeline that's great and that's solid and flip it. And it's not rocket science. This isn't like a crazy new concept, right? It's things that we do in our production environments with the products we're creating. The pipeline is our product. It's things that we're creating to run the business and get things out. And really, all this stuff was just a 3 ways, right? So this is, Edwards Deming. This is Gene Kim wrote about this in the Unicorn Project. Flow, feedback. I wanted Dave Grohl, but couldn't find him. And experimentation, right? So this is just implementing the 3 ways in a production or a green pipeline to make sure that it works before we're actually using it, and abstracting the testing and not testing in production. So some advice. Sorry about the shirt. I think I ruined Endgame for somebody. But just before Thanos snapped his fingers in the second Infinity War, he said, "I am inevitable," right? And then Iron Man ends up taking all the Infinity Stones, and he doesn't really understand what the heck happened because he snaps his finger and nothing's going on, nothing happens. So he's like, looks at his gauntlet and he's like, damn it, like he just failed, right? He failed to kill half of the world. And then Iron Man is sitting there and, anyway, failure is inevitable, so prepare for it. And if you know things are going to break, or things could break, don't do it in production, and especially don't do it in a pipeline where you're actually trying to get code. And the code is it's the essential part of what the business is, right? It's about getting product out, quality, safer, sooner. All the things. So code all the things. Infrastructure is code, right? SQL Server, people writing Transact SQL, they're sort of the original gangsters of infrastructure as code. That's been around for years, right? Deltas, chain sets, all that kind of stuff. But do the same with code. Like, who uses a Terraform or Ansible? Or if you don't, God, please. But it's the reproducibility, especially from an audit perspective, right? If you're creating infrastructure, then you start to get away from your whole separation of concerns because it's separation of systems, and you have the reproducibility. You can look at it and somebody can come in and say, hey, you know what, this is great. And I understand what's happening in the infrastructure being created. That's either for your development tools or your production environment. Like you were saying earlier, that it's everywhere. Like you can do one thing and have it everywhere. And if you do a production pipeline, code the whole thing. Right? So you're coding that deployment, you're coding the scanning, you're coding how these systems interact. You could be doing attestation saying, you know what, we need to make sure that all these security scanning tools are done because of our compliance, and then audit them and say, this is where they are. So I can prove to my auditors that from a PCI perspective, I'm doing all these things that I'm supposed to be doing. And then it's easier to just create that replica environment because you're just pointing that infrastructure at another place and just running it. And then swapping them around as well when you're satisfied. So focusing on quick wins, right? Get those tools, security or otherwise, in that pipeline. Tweak it, see if it works well. Nice. And focus on that. Focus on getting something out, and then even if the tool is out and it's in your production pipeline, it's working satisfactorily, you have satisfaction with how it's operating, still keep on with that green pipeline and tweak it. Just see if you can optimize it, look at it. And as you're going through and you're adding other tools, removing other tools, you're just continuously improving the efficiency of how you're delivering software. Maintainability. Make sure that you can actually maintain that system, that you have the plans, the documentation in place, that once you do flip it, if something goes wrong and people take it out or can take it out, or maybe they can just stop the scan, bypass it, work item gets created, some sort of incident, maybe it goes into service now and it's like something you got to deal with. Make sure that you're not just leaving people high and dry, which is what we did with the security organization, adding that tool in. We just thought, yes, we have static analysis, and then it's like, oh damn it, we just broke everything. Try again. Keep improving, and then fight uselessness. So if something isn't useful, get rid of it, right? Just many tools, many complexities, not really good. And don't boil the ocean. This is actually a boiling ocean, and it might be volcanic. I don't know. I don't know how oceans boil, but apparently they can. But don't boil them. Just stick to something simple. Open source software scanning. Just a lot of vendors, not just who I work for, but this thing, based on our state of the software supply chain that was done last year, surveyed a ton of folks and came up with a statistic saying 85 to 97% of any software that you write is not software you write. It's something that someone else has. So don't scan that with some tool that's looking at every single line of code. Use something that's fast, that's 50 seconds. Right? You can scan that 4.8 million lines of code, all the dependencies, in less than a minute. And that is what speed and operations and DevSecOps, DevOps flow is all about. And remember that toothbrush. Do what's essential and nothing else, and make sure that you have the essential components in the pipeline. And if they're not useful, rip them out. And that's my talk. So I think we got under it a little bit. My email, you can just send something to DJ at deliveryconf or plus deliveryconf at sonatype.com. I have an autoresponder in there. You don't have to sign any forms or anything like that. You get my slides. Also, there's that State of the Software Supply Chain report link. There's that crazy boil the ocean architecture. You can download that from there too. And again, you just get an autoresponder in a few minutes, and it'll be on for today and tomorrow. So if you want any documentation, check it out. It's all in the auto reply. With that, thank you.
In our case, particularly with Jenkins, we tried something like this, and really we're using scanning, right? So it looks for the Jenkins file. There's not, other than branching, there's not, and because we source our pipeline files. Well, we do one thing, which is import libraries from another project, and we use a branch to pull those in. But we aren't running them in parallel. I guess what I'm wondering is what you're using, and any suggestions for dealing with that problem, if that made sense.
2 Jenkins. I'm not kidding. Repeat that whole thing. So you're still looking at that single. So it's like continuous integration, right? You just have one branch as trunk. Everyone merges things in, scares the crap out of everyone, but everyone pulls the assembly line and fixes it, right? So having if you have a Jenkins server, you have another Jenkins server, and you can test the configuration on one, test the same configuration on the other, and it sounds annoying. But once you do it on one thing and you copy it over, or you're not even copying it over, it's just a script, right, to bootstrap everything. Use a Helm file, create that whole infrastructure in one swoop. Annoying, yet very valuable, especially when you don't want to kill something, right?
Worth the investment, you're saying?
Yeah, absolutely. It's it depends on what your pipeline is and how you're configuring things. Like a lot of times, folks will. They'll have Jenkins, and that's running their whole pipeline, or GitLab, and it's running their whole pipeline, which is great. But then focus on the configuration and the creation of those scripts that are building that pipeline together.
Good. Somebody else here? Another challenge?
Oh yeah. I wanted to ask. I'm just not very familiar with like variety of pipeline building software, but I'm just wondering if you do make a couple of experiments, how do you document it? I guess at some point somebody else will see two pipelines and like, why there are two pipelines, and now they either need like a really good diff software, or just know what happened there, right?
It's just automated scripts, right? So it's a Helm file, one Helm file, maybe two targets, say like make green, make blue, bam, bam, right? If you can do it in production, or you can do like build a pipeline in production, you can do the same thing. So yeah, documentation, good README file, good repository README with some like good build scripts. Because if you're doing infrastructure as code, it's really self-documenting, right? Or you should be able to understand what's happening from a procedural perspective. I prefer not to write documentation at all. Like, I assume that if I can write a comment saying this function is for this, or this part of a make file does this, or put a README file together, eventually it'll start growing and people will start adding more things to it. So hopefully that gets away of the ambiguity.
And maybe another challenge is maybe in the domain of accountability. Like let's imagine a team in which dev and ops are slightly separated, and experiments that ops might be performing might not necessarily be known to dev, just for the sake of example. And let's say, if I understand correctly, both pipelines deliver to some sort of, well, actually to production, right? So imagine that like a case of monkey with a grenade, like, I don't know, certificates got stripped off, and now anybody can access without HTTPS only the roles. Like how to maintain accountability and manageability of the experiment for the green.
Sorry, lights in the face. So who's your customer at development then? It's operations, right? And when you think about it, that's sort of Franken DevOps, where you deliver, you do your testing, everything comes in, and all of a sudden it's like, oh, there's ops, and you throw the grenade over the wall, right? So you could do it almost two ways. Like ops might have their own pipeline that ingests the deliverable from dev, and then you sort of have that continuity. They might not have a blue-green type of thing. Maybe your green is you're getting to the point where that would be an artifact that would go over the wall. Try not to have a wall. But that's a cultural thing too. Like that gets into a bigger issue. But just from a process and procedural perspective, again, like it's a concept that you can apply, but everyone's implementation is going to be a bit different, right?
Okay. How are we doing on time here? We ready to?
Yeah, we can move on.
Sweet. All right. So does anybody have successes that align with this discussion that they want to share? I see some. Yep, come on up. Go ahead, man.
Oh, thank you. Yeah, we have a similar process, although we use, we've got several different environments. We've got a sandbox and a pre-prod and a production environment, and they each have their own pipeline. And we're testing our changes to our pipeline in those three successive environments as we go. And we're just doing that off of, based on Git branches. So we just have three targets: sandbox, pre-prod, and prod, or master. And those will push to our different environments, and our pipeline experiments are all encoded in that. So they've gone through three different environments by the time they get to production.
So Matt, you have a story you were sharing with me earlier about environments that you're creating from a CI/CD perspective that can run in different places.
Yeah. My success story on this involves moving pipeline configuration as close to the application code as possible. And so, in fact, I keep all my CI and CD configuration, in the application code base. And so then, when you make a pull request, my pull request may be changing my pipeline configuration, and so I'll have a full test and PR branch deployment and automated testing against a branch deployed review environment, as part of the normal dev process, and that absolutely removes the the wall between a change to an application or a change to the way that we manage and deploy and process that application. They become the same thing, and that really enables the same people that build the application to be able to change the way that application is deployed to the world.
Other success stories?
I guess I can say that maybe like I touched on using externalized libraries for things that are common and shared has been a great way of handling, keeping the complexity down. It doesn't make it go away, obviously, but at least it dries it up a little.
We actually also do that. So we have Terraform code that defines our pipeline. So we're using code build primarily for our pipeline, which makes it a lot easier because you can just instantiate that through Terraform. We have modules that sort of define what our typical code build environment looks like. We have the build spec file in each repo for the code that it's going to build. And we've got one main repo that defines all of the pipelines that we have, and then the code repos for the code that those things are going to build define their build spec. So anyway, yeah, we've got it all and tagged on, or it's all keyed off of Git branches. So you check in your code and it all happens automatically. In Sandbox, we allow developers to sort of monkey with things manually, but then you do a PR to the pre-prod environment and nobody ever touches that stuff manually. It's all happening through code and modules.
The other thing that's cool, we were talking about this with Terraform, is that when you do a plan, you're getting your deltas right there. And then you can test or write unit tests and test cases around the plan and what's expected. And then you can just apply things into production from that perspective, which scares the crap out of people. Like, oh my gosh, your infrastructure as code is just going out. It's like, yeah, but we expect what's happening, right? And we know what's happening because we can do it on this green side of the house, at least for our infrastructure, for our pipelines, which is, but you can also do it for other environments as well.
To that point, when we issue PRs, we're doing a Terraform plan. It's built into the code to do a plan. And then if somebody approves that PR and we merge it, then it does an apply without a plan.
Our speculative question is our final C question. If you had a wish list, if you had a magic crystal ball, what could treating our deployment pipelines as the dynamic creatures that they are look like in 2 to 5 years? And this can be a broad question. This can be about the mechanics of getting code from a laptop to a production environment. This can be about compliance. This can be about auditability. This can be about the dynamic nature of it. A very broad and open question.
So vendor lock-in, that's a big problem, right? I'd love to see the ability where things could be open across multiple cloud platforms or vendors. One of the things that we did to sort of abstract things is having, we weren't using plugins for Jenkins from any specific vendor. We were using a command line or shell activity that would run, that would call into an API, but not actually couple the pipeline to the API. So we could just swap vendors out, and vendors could be disposable at the time, or the tools could be. So I'd love to see a point where these changes to our infrastructure, our pipelines, whatever these things are, become painless. So I'd love to see that in the next 5 years.
Any other hot takes?
What he said.
Yeah, to add to that, I mean, I guess just I'd love to see this progress more, and on the idea of branches, like, it'd be nice if you could have your whole CI/CD system running on your local machine and testing things there, and then being able to push that. And as you do feature branches, you don't have to have established environments set up. You can just build a pipeline and run your code through it and tear it down and see if that all worked.
Sure. So that's actually something that I do right now. So Brian's reference architecture from last night is what I do in that I use, so for example, I use GitHub Actions right now. And the unit of composability is Docker containers. So all of my pipeline actions happen in Docker containers. And the unit of composing is YAML, which we can agree or disagree on whether that's good or bad. But it's there in the application repo. So I use EKS generally, and I use Flux, which is a tool for syncing Kubernetes manifests out to a cluster. And so if you make a PR in an application repo, GitHub Actions will go ahead and run tests and build artifacts and push Docker containers to a registry. And then it'll template out a Kubernetes manifest for an environment, and it'll check that into a manifest repo. And then Flux will see that there's been a change to the manifest repo and a new environment has been specified, and it will sync those applications to the cluster, and it will spin them up and pull the containers in from a registry. And so fully dynamic environments is totally a thing that's achievable now with modern platforms like Kubernetes. And then you close the PR, and there's a GitHub action that fires to go and delete that manifest file out of the manifest repo, and it goes away. So that's one sort of fully dynamic pipeline all the way through to let's create infrastructure on the fly.
All right, don't be shy. I'm sure there's other, if you could wave the magic wand, what's on your wish list?
Maybe one of the lacking some of those capabilities, maybe one of the things I would like to see is the ability to kind of have, along the lines of what you're saying, lower the cost of doing this. Like maybe a dry run mode that doesn't actually ship binaries and that sort of thing. Be able to exercise the pipeline, not actually send messages and Slack messages to people and things like that. That's the sort of detail maybe I wonder about this.
So you might want to test it, right, to see that those messages go through. But is it essential that they get everything? And that's maybe sort of part of that experiment. It's like, who's your target audience? Do they need to see what you're saying? And if they don't, can they unsubscribe for it unless they have a role that mandates that they get it? So that's one of the things we were trying to do and trying to get to, is that maturity of the right person, right message, and if it didn't apply to them, they could, unsubscribe, but only if their role let them.
Question. Would you have both, let's say blue and green both send a message, hey, we've this new deployment ready in this exploratory testing environment. Do both send to the recipient of that, or you're saying the recipient of that would subscribe to what is only active and not subscribe to what is inactive? Does that make sense?
Yeah, that makes sense. It's like, are you going to send messages from a test environment in production, right? And, I guess that could be a separate Slack account or a separate, where you're replicating it, or it's an environment variable that says, okay, we're going to use this channel until we actually need to fire it. But I wouldn't fire anything directly to somebody. I'd always fire it to a group just in case that one person gets shot, or not shot, but, the pink slip, right?
I usually say they win the lottery and don't show up the next day for a more positive spin.
The circus factor.
I think now that I think about it, there is some level of similarity. We were talking about flights, like when developer, with help of some cool scientist, statistic guy, can put some tweaks into the behavior of the system, and then if there were enough hits based on the traffic, some conclusions could be made. I feel here it's very similar, just on a very on a more sensitive subject, I guess, because it's a pipeline. If you fail, it's very bad. But you might still need to run a number of experiments before it's statistically providing valuable information. And you might also be in need of some tools that tell you, okay, this was the experiment. This is what we expected to see. This is what we saw, and whatever conclusions to draw from that. So I think in terms of wish list here, maybe that higher level tooling on top of that methodology, if it becomes more popular, I guess.
That when you say experimentation, I think of chaos, right? So James Wickett I don't know if anyone's seen his talk where he's talking about, well, he works at Verica, chaos engineering, Casey Rosenthal, all that kind of thing. But doing chaos experiments against your pipeline to test its resiliency and test what you haven't tested, that could be cool too. I was just thinking about that when you said about like experimentation and, just applying the unknown and trying to break it. From a chaotic, not chaos monkey necessarily, but you know what I mean, like well thought out experiments that you're saying, hey, what happens if this happens? Like it's the same disaster recovery, like we have disaster recovery plans or, in our production environments for our products, but a lot of times we don't have it for our delivery process.
Something that occurs to me is that I feel like there's a lot of value in front-loading as much of the complexity as early in the build and deployment process as possible, because you're always going to have a singleton at the end. You're always going to have, the one thing that is the production thing that we don't want to duplicate or we can't duplicate. And even if we could make, 12 intermediate environments in between I commit code and production, none of them will really look like production. So if we want to change security scanning, for example, let's try and do that at the place where we can afford to have 10 of them, which means, as early as possible, in that if I'm making, PR branch environments, then I can have 10 environments with 10 different configurations running, and I can do that sort of work before I have to commit to going to production. So shorten the number of things that are singletons at the end, and push as much of that complexity at the beginning where you can parallelize and you can experiment, with less risk.
I'm interested. Why do you think it's a singleton? Just because pipeline is infrastructure as a code, and there were these cool guys with DNS solutions and stuff. Technically, you can spawn as many as you want, as much as you have money for, and then just manipulate with traffic. You can say our marketing department of my company goes here, sure. And so I think I can see why singleton, like traditionally, will be thought here, but we should be probably past singletons there.
Sure. I think, we were alluding to it earlier, like I would like to send a Slack notification when I make a production deployment, but I would not want to send a Slack notification, when I make an experimental or a test deployment. And so now we have a behavior that we only ever want to have happen once, and that's now a special condition. Right? And so if we have a special condition, we can't test that elsewhere. So the plan would be to have as few special conditions that only exist in one place, that only exist in production, and make as many of those tasks parallelizable, rather than accepting that we'll always have some large number of special cases that we switch off. So if I have 3 pipelines, I don't want to turn off a bunch of my stuff on 2 out of those 3 pipelines, because I'm not really exercising the entire workflow.
So, I used the automobile manufacturing analogy earlier. And if you think about how cars are actually made, the engine's not made on the same assembly line that the body and the chassis are made. And the paint's not done on the same, as the frame is made. So you have these sort of mini pipelines that all converge together to make a car. So, one of the things that freaked out some of the management at CVS, whatever, was that we could have potentially 3 different configuration pipelines that were doing different things. Like, you're not going to have spray paint on an engine assembly line, right? You're not going to have motor oil on the, maybe you do, on the painting line. But letting each team determine their own destiny, it's all coming into this one vehicle at the end. So I think that's what you meant by singleton. It's like there's a product coming in at the end, and it's one product, or could be multiple microservices or something like that. But each team might have their own way of doing things.
All right, this has been a very productive and enjoyable discussion. Thank you again, DJ, for your talk. Thank you all for participating. We'll see you at 4:20 in the main room. Thanks very much.